right. Okay. Did you get 13 there?
Yeah.
So for 0 to 1, did you get normal V? And from 1 to 2, opposite V? Yeah? Do we agree? Jay, do we agree? Are you with me?
Yeah. I didn't get that far yet.
What the heck have you been doing? What have you
Trying
people been
to
doing?
figure it
You've been
out.
stupid.
Mainly I make thinking about scholarships.
It would have been, I was getting zeros on V from 1 to 2, yeah? So wouldn't a parabola be below it, 1 to 2? Yeah, it's the distance is the integral of V, not x. So you need to take the derivative to get the velocity function, so you can know, when it's moving forward and backward and make those all forward. All right, so x at 1 minus x initial minus, I'm skipping a step, I shouldn't do that. Just do things the right way. X from 0 to 1 minus x from 1 to 2. Okay, so looks like the distance should be 2x at 1 minus x initial minus x at 2. Now, question is, what's x at 1? How are we doing? Surely not everybody's behind me. Somebody's ahead of me. Are you getting this?
Yeah.
Cole, how you doing? Cole, I'll believe it. If you say, I look good, then I'll believe you. Am I good? Are you with me at all? Okay. Cole's the kind of fly under the radar, really freaking smart, but nobody knows it because he never says anything guy. Yeah.
Everyone knows it.
Oh, really? You guys know that?
Yeah, we're aware.
Oh, okay. He's really smart. Minus 13. Okay, so you just don't care. I get 6. What about you?
Yeah. I got 6. I know it.
I got a really cramped box.
Okay, a lot of places to make a mistake.
I got negative.
Negative what?
Negative.
Should never get a negative distance.
I know.
I am negative.
Oh, you probably forgot to put them added from 1 to 2. No, not you. No, I got that.
So, do you have x of 1 minus x initial minus x of 2 plus x of 1?
Oh, I'm dumb.
Oh, all right. Yeah. So we good on that one too. Checo? Oh. All right, number 9. Look at number 9. If you can't find a mistake in 2, let go.
That's infinity.
Oh. Using 6th grade. Understand what it was. Okay. So set 90 was distance and integrating absolute value. Are we feeling good on set 90 number 2? Okay, number 9. In the interest of getting a little quicker, what is e to the negative infinity approach?
Very small fraction?
Very small. Okay, what about natural log? What does it approach as x gets bigger? Infinity. And what is that? Is that just 0? Because 0 times anything is 0, right? No, because it's not 0. It's
Tiny.
approaching 0, not is 0, approaching 0, and approaching infinity. And that's not 0. That's, I don't know. Depends on how small this gets, and how quickly, and how big that gets, and how quickly. And if I say how quickly, I need to investigate the rates that they get big and small. And if I need to investigate the rates, then that means I need to look at their derivatives. And if I look at the derivatives, that means look at L'Hopital. But to use L'Hopital, I have to make it a fraction. All right, so your first objective, once you see that, oh, this is that new indeterminate form, make it a fraction. Which one makes sense to put in the denominator?
E to the x.
E to the x. All right, so we can agree that this is the same problem. Now it feels like infinity over infinity, so now what do I do? Now you do normal L'Hopital. Okay, so you do L'Hopital work showing that it's indeterminate, limits separately. I don't like the way that looks when I take derivatives, so I would rewrite it as 1 over x e to the x. What do you think? Okay, then what does that do as x gets big? Goes to 0. What does that imply about which one won? The E1. Yeah, go figure.
E is strong.
E is powerful. All right, so here we go with the lesson. Are you ready? This, I think, is the last derivative technique, until you get to partials, which is in Calc 3, that you have. You have one technique not in your toolkit. And that is, how do you take the derivative of an inverse? So, let's go here. You have these notes in front of you. Okay, this would be in the green derivative technique chapter, usually the last one to learn. All right, so I gave you a table of x and f. Would you please give me a table of x and f inverse? You have 3 seconds. Go. 1, 2, 3. What's the x row, Harper?
7, 11, 14.
Harper, your voice is so deep.
I didn't get that.
They're so handy, Harper. Egan, what's the inverse row? Yeah. So one of the big ideas of inverse is that it involves the old switchy the x and y, right?
Right.
Okay. Now, what about in terms of back in the day proving two things are inverses? How do you prove they're inverses? Actually, just read the box over there. I told you.
The f of like g or first then g of x.
Well said. So let's try this in a normal. My teacher taught me function machines. Okay. So imagine these are a little function machine. I'll call this f. All right. And f takes numbers that you input and spits out an output. So for example, if I input a 3, then what would be output?
5.
A 5. Okay, there's a little function machine, f. Now, I'm going to follow f with function g, which takes inputs. Oops, I should put the input over here so it drops in, my bad. Okay, and it will take what you put in and subtract 2. So what if I put in a 3 into f? What comes out again? 5, but then if a 5 goes into g, what comes out? 3. So you can see that g undid, and you're right back to where you started, right? Speaking, you could say if you just put in any old x, then x would be put in, what would come out? X plus 2, but if that's put in there, then x plus 2 minus 2 is right back to x. Inverses and functions that each other's results or outcomes. So, what is the inverse of f equals x plus 2? X equals f inverse plus 2, or f inverse is x minus 2. In other words, the inverse is x minus 2. If the original function is x plus 2, the inverse is x minus 2. With me? Okay, now if I wanted to prove, not say, hey, they're inverses, prove they're inverses, then you would have to do the composition. So if you put f inverse into f, then what goes into what? X minus 2 goes into f. So it'd be x minus 2 and then plus 2, and you get x. Now it is possible that you can get an inverse that works one way but not the other. Arcsine, for example, because it's limited, has this condition. So f inverse and f. So what are you going to put into what now? X plus 2 into blank minus 2. If x plus 2 goes into input minus 2, then they also come out to x. And so we could conclude that our inverse is correct. You follow me?
Yeah.
Okay. Would you find the inverse of f implicitly and explicitly and label each when you find them? Explicit does not mean like this album is explicit, it's got cuss words. Explicit means clearly stated. Not implied within. ¿Listos? Okay. Tyler, how do I find the, what do I do?
Change x y.
Okay, so you guys use what? So some use what? I would use f inverse, but whatever you like. I like y, I like f inverse because then it looks different than normal. All right, so what have I already done? This is implicit. I just found implicit. It's implied within. The inverse is implied within. It's in there. It's not clearly stated. I didn't solve for it, but it's implied. What the inverse is. You follow? Okay. More work is explicit. So what do I have to do to get explicit? Lindsay?
You solve for
The inverse. Okay. So what should I do?
should move the 3 over,
Okay.
and then divide it all by 2.
Oh, so
And then
exciting.
take the natural log.
Thanks for calling you more. It's so fun. It's like suspense almost. Well done. So we're good? Any questions there? That's the explicit. Label it, please. All right. Now, obviously that's not calculus yet, but we're going to get there. I promise you we'll get to there. So, would you graph that polynomial and then sketch the inverse? I have no doubt that you still have your polynomial graphing skills as you've been canonized. I have it. What does that mean, canonized?
It means that you can get shot out of a cannon or
No, canonized. Canonized, you are declared a canon, saint. Canon.
Oh yeah, that is right.
No.
don't think position B. No, canonized as in you're not non.
I follow the Church of the Subhuman. My church doesn't believe in that. Yes. See.
Okay, what's the overall shape in the air? Show me. Okay, what are the zeros?
-2.
-2 and 0. Which one does it not change sign at?
-2.
-2 because of the even exponent. Okay, so something like that, except not passing through -2 like I did. Okay, cool. Give me 1 point on the inverse. Cindy, give me a 1 point on the inverse, pal. What? 0. 0, the 0 is not a point. That's a half a point. Try again. There you go. Boom. Okay. Oh, you did? Stop, Mom. All right. Give me another point. Lauren, give me. Quicker.
Okay, sorry, 0, -2.
0, -2. Yes. Okay. All right. So I know it's got to go through those points. So what does it do? Is this right?
No.
I don't even know where to go from there. How about this? No, it should bounce off of to the -2 points, so it should go like this. What kind of symmetry? Symmetry across? Y equals X. Tell me why that makes sense that it would be symmetric across Y equals X. Yeah, when you switch X and Y, if I took this axis and switched it with this axis, wouldn't it be just right across that? Yeah? Okay, so there's symmetry across Y equals X. Good deal. Now, the stage has been set for calculus. Here we go. Understand the inverse derivative graphically. So, would you, I don't know why I have these random lines here. I imagine you don't have these lines here, yeah? Oh, those are raised, I guess, my bad. So, would you sketch the square root graph, please? Accurately, at least at the ones that are rational y outcomes. Okay? Mine's not very smooth. You can get the idea. You with me? Okay. Now, will you graph the inverse, please? Okay. Now I'd like you to draw the tangent to the point. I actually have to make sure I understand what I'm talking about. It says the tangent at the point corresponding to x equals 4 on the inverse. So what corresponds to x equals 4 on the regular would be this guy on the inverse, yeah?
Yeah.
Okay, so if I draw both of those tangents, would you draw the one at the original curve? And then draw the one to the inverse at that matching point, 2, 4 instead of 4, 2, yeah? All right, now the goal is to see visually, when you take a derivative on an inverse, what is it? Where does it come from? What does it have to do with anything? Does it have any relationship to the original? Probably does. It's probably not just random. So, what does it look like this slope is? Maybe up, definitely positive, maybe up 1 over 5-ish. Okay. What about the other one?
5.
More like 5 over 1. It's definitely the case that the sign did not change. These are not perpendicular. Students want to be, oh, it's opposite perpendicular. No, it's not. Okay, it's not perpendicular. It is, however, inversely related or reciprocal related. Steep and flat, flat and steep. So it seems like maybe the matching inverse point has a reciprocal relationship. Reciprocal? Question mark? Let's do a little more exact, okay? Now the best way to go to get the derivative rule is what we talked about earlier. Didn't we say that if two things are inverses, they should undo each other and you should be right back to the x, yeah? Can we say this is true about inverses? You follow me? Okay, now it might seem weird to go there for the derivative, but that's where you're going to go for the derivative. So would you take the derivative on that so we can get a rule for the derivative of the inverse? Go. Listos? Quicker. Right off? You good? We'll see. I'll be the judge of that. All right. So I think you'll agree that the derivative of the left is a chain rule derivative, yeah?
Yes.
So where's the derivative of the outside? F prime of n inverse, or the inverse. All right. Times the derivative of the inverse? F inverse prime. That notation is terrible and, like I said, clumsy, but it is what it is. Okay? Equals 1. What are we trying to do again?
Prove that that exists.
No, not prove that it exists. Figure out what it is. So we want this. We want the rule for the derivative of an inverse. If I isolate that, the derivative of the inverse is 1 over the normal derivative at the inverse point. That's kind of what we said before, not quite as clean, but didn't we say it's 1 over the normal? Kind of here, and the point switch, because it was 4 here, is actually 2 there, so it's more like the inverse point. So you can kind of see where we were coming from there. All right, so oops, that goes there. You get that. Write it again. You with me? Let's see how it works then, okay? So say I have G inverse prime at 2 is what I'm looking for, and I give you that G is x cubed plus x. All right, now I don't want you, students like to do implicit here, and that's definitely not the way to go. Instead, say the derivative of the inverse is 1 over the derivative of the normal function at the inverse of, oops, 2. Shucks. Actually, I think I'm going to, what I want to do, yeah, what, all right. You done? Okay, now, what do I do? Then, take the derivative? Not yet.
The inverse.
Yeah, you really need to know what I'm going to be putting into the derivative first. So let's do the inverse. G inverse at 2. G inverse at 2 can be found by guess and check. Most books focus on easy to solve stuff. When I say G inverse at 2, in terms of the original function, where would the 2 go? In the x or the y?
G of x.
Okay, this would be like 2, G, I wrote that bad, sorry. Okay, let's write this at least once for your notes. 2 in the inverse, or x equals 2 in the inverse, is like y equals 2 on the original. You follow? Okay, so if I want to know what's G inverse of 2, that means go to the original and say, well, if the y was 2, what would make that outcome? Now, obviously, you've got a cube equation, and it's possible, I guess, if your teacher's just a total jerk, he could make you bust out all those cube skills you once had last year, but you've definitely forgotten. But these are guessing checks. So what's x? That's 1. All right. Now that said, then, this is G prime at 1. Now I still want you to do good calculus, which is to say, show the reader, hey, this is what the derivative is somewhere. I typically show it here and say, I'll put in one in a minute. First I'm going to show you my derivative. What is the derivative of g, the original g? 3x squared plus 1. And then if you evaluate, then you get 1/4. Okay? You follow?
Hello.
All right. You try. What did you find g inverse of 2 at? 0. True. So, your answer is? 1/2. We all agree? 1/3. Did you take the derivative and keep that 1 in your derivative? Okay. All right. Try. I trust that there's a point to this. I think there's something new to be added here, so let's go. G inverse prime of root 3 over 2 is 1 over G prime at G inverse of root 3 over 2. Oh, I wanted to review Lavazon. So where is the inverse sign of root 3 over 2? Should have made a negative thing. Pi over 3. I agree. Pi over 3. Why didn't I make it negative? That was dumb. Oh well. What is G prime? Cosine. That's an exceptionally long time. What is cosine of pi over 3? 1/2, and 1 over 1/2 is 2. Okay. All right. And is there a point to this one? Is this hard?
There's
It's odd. It shouldn't be. Oh no. Okay. So I don't know. That is very much what I wanted to talk about, but I don't feel like this is a possibility. Okay. I don't know if this is the problem or not. Do you think there's 2 solutions to this? Isn't it? It's 1-to-1. It's monotonic, so it's not that. But so I think maybe it's just meant to spur a conversation. So here's the deal. If, just for the sake of notes, if the original is not 1-to-1, then the inverse is not a function. Now what that means for the derivative, there could be several derivative slopes possible in those cases. And it just occurred to me that you don't know a calculus word that they often throw around in college. Maybe you do. Have you ever heard the word monotonic? Get it on your notes, please. Monotonic. monotonic functions are one-to-one because their derivative has one sign only. Now think about that in terms of derivative has one sign only. What would that imply about the function's increasing or decreasing behavior? It would either always be increasing or always be decreasing. And if it's always increasing or always decreasing, doesn't that ensure that it's one-to-one? See what I mean? Okay. Calculus or AP style questions. Give these two a go. Have we ever talked about the rule of 4? Does that mean anything to you? Did Ms. Tannen talk about the rule of 4? Okay, well, the rule of 4 is that you should understand math analytically, graphically, numerically, and verbally. So, for example, you should understand graphically what exponential growth is. You should know analytically what exponential growth is, which is to say you should be able to manipulate the equation. You should be able to recognize from a table of values what exponential growth is. For example, something like that. Hopefully you could say that's exponential growth. Or I could say the amount grows at a rate proportional to the amount. That's exponential growth. So, understanding math on 4 levels. I'm asking here that you show you understand inverses on a graphical level or a numerical table level. Go! So for the first one, are you doing the equation and all that stuff, or are you just using the graph?
Graph.
The intention is that you just use the graph, and you sketch the inverse. The inverse looks like that in red. And what's the slope of the red at 2?
1/2.
1/2. Okay. We'll use this. Ready? Okay, so this time I am using the derivative idea, the analytical. I need to know the inverse of 2. So in the table, do I say x2 and look at the y? Or do I look at the y's and find the x? Yeah, I need to find where the y is 2 and say what's the x that made it. So the inverse of that, g inverse of 2 is 1. All right, now I can go to the derivative row. The derivative at 1 is 7, so did you get 1/7 for an answer? Very cool? Okay. So, I'm not big on memorization, but it is kind of handy to have this memorized, so give this to me. All right? Questions on whatever you have questions on that's math related. I don't want girlfriend questions. Okay. 80, do you have 90?
17.
90, 17?
No, that's on 91.
Oh, sorry. 90, I'll do 91 in a second if we get to it.
Hold on.
90, 90,
Can
should I just do them in order I get them? 91, 17?
you get 10 eggs?
90? Okay.
91.
90, number 1.
And 6.
And 6. Okay. Listos? So 90, number 10A.
Wait, you read two of these? How did I miss this other one?
Okay.
Oh, yeah, that's right. See, I didn't even see this. Oh, no, that's like really wrong problem. I look like fully like I look like.
All right, so the amount's coming in, which means they're proportional now. After 1 year, 11. So, wouldn't you agree that 1,100 is the result of taking 1,000 e to the r after 1 year? When it's compounded continuously, it's an E kind of equation. If it was compounded annually, then it might be something like that. Which we don't do a lot in our book. We probably should practice. But do you see where I'm coming from here? Yes? Okay. So if I solve this, I get 1.1 equals e to the r, and therefore the log of 1.1 is r. If they wanted a percent form, then I would have to adjust that. This is going to be the decimal form of the interest rate, I think. Bless you. I get 0.0953, yeah? So something like a 9.531% interest rate. Does that make sense?
Yeah.
Okay. Is one still a question unto me?
Yeah.
Related rates. Okay, this will help in case you tutor an AB kid, because they are struggling mightily. 90, number 1. We've got this cone, and I think it has the cup itself is 4 by 4 in diameter and height. We've got fluid within that is changing, and so in the related rates process, I believe you were told, and most people say, that you should establish and write down your givens, showing that you understand verbal calculus. So when it says water is dripping out at a rate of 1/2 of a cubic centimeter per second, what is that in calculus you're given? If the water is dripping out, then that's decreasing rate. And if it's cubic centimeters per second, what rate calculus is that? The xdt, the rdt, the hdt, the vdt? Whose question is this? Am I done? Okay, I guess I'll probably give it. 6. Is 6 still a question?
Yeah.
Okay, 6. Maybe. Okay. Yes. A lot of common errors here. The drops a ball from 576 feet, and I've had a lot of questions on this in the last few days, and I've seen a lot of small little errors. Average height, yeah? Okay. First of all, what did you use for acceleration constant? Negative 9.8? No, because in this case it's feet. So first thing, if you had an error, make sure you use negative 32 instead of negative 9.8. We're cool? Now I can't find average height until I know the height equation, yeah? All right, so how do I get from acceleration to velocity? Again, I feel like I know. You integrate. So negative 32t plus a constant, yeah? Says they dropped it. So what does that imply about the velocity at time 0? 0. So the velocity is merely negative 32t. How do I find height? But you integrate velocity, so isn't that negative 16t squared plus a constant? And it says that you dropped it from a height of 576, so that implies that C2 is 576. Are we cool? So, our velocity equation is negative 32t. Our height equation is negative 16t squared plus 576. And now we want to find the average height. So, I've had two different approaches I've seen here. Average height, is it 1 over, oh, we still don't know the time frame, right? How do I know when it's in the air and when it's not in the air? There, and I believe that's at 6, yeah? Okay, so, is average height this, 1 over 6 minus 0 from 0 to 6 of height, or 1 over 6 minus 0, 0 to 6 of velocity? Which of these is it? The first one. If you want, it's the average of the function you're looking at. If you want the average height, then you use average integral of height. This is not it. People think, oh, don't you want to integrate v to get h? No. Then you would have that. Yeah. What is that?
Average velocity.
That's average velocity. Go figure. You found the average value of velocity. That's what you just found. So if you want the average height, then height is in the integral, not velocity. Integrate from 0 to 6, negative 16t squared plus 576. And call it good. And I think Dunner, 16?
Yeah.
A or B or, oh, the one I added with the both variables or something like that? Yes?
Yes.
Okay. So here's 1, here's 2. All right. I still am struggling getting people to draw rectangles. They feel like it's not necessary, and it is the idea. It's the big thing that gets you going. So if I draw a rectangle this way, which would mean dx, and revolve it, then what's made? Shell. So if I use x, I get shells. Okay? Now, let's say I go the other way. If I slice this way, I think, oh, yeah, I guess I should make a couple slices because they're different. These rectangles are dy, and they seem like they are this. Okay? And furthermore, it looks like I will need two integrals, all right? So, shall we talk about the shells, or you go with the shells, just the washers? Just the washers, all right. So, I'm going to highlight this lower region here. That's the region where you're just going between the two straight lines, the vertical lines. So, volume of that shaded region is pi big R squared minus little r squared. And is it dx or dy for the heights of those washers? dy. All right, what's big R? Big R is from the center of the axis of revolution to the outside of the washer, and that is 2, and it's always 2, no matter where I do those slices roll, right? Little r is in here, it's the circle being removed, so what's little r? 1. The limits of integration, because they're y, it's not just a normal 1 to 2, it's a little more complicated. I think we can see the lower limit is 0, and that's easy enough, but what's the upper limit? This is the upper limit. What is it? Is that when I put 1 into the curve or 2 into the curve? 2. 2 into the curve gives me what result? 1/2. Okay, the upper region, up there, is pi big R squared minus little r squared. It's dy. What's big R now? Feels like it's now the distance to the curve, not to 2. So it's the curve, but in y terms, and that is 1 over y. And the inner r? Still 1. It starts at 1/2 and ends at 1. And those should be the same. I think it just said setup, but they would be the same if it's not. Are we cool? All right, that seems like all we're going to have time for. So 90s due. You can keep 91. Maybe we'll get caught up tomorrow.
So in the back of the book, it has why squares is question mark this.
Yeah. So there's if you multiply through by 2. Have a great day, people.